Hi there, my name is Aaron Abbott. I'm a software engineer at Google. I've been working on the OpenTelemetry project for about 2 years in the Python SIG mostly and the metric SIG. Josh is an OTel technical committee member. He helped with the content of this presentation, but he could not be here today. So this talk is about instrumenting your applications for metrics, and we're going to have a developer demo as well. So first, what are metrics? Metrics are time series data. They're created by aggregating together measurements from an application over a period of time. So because you're aggregating your measurements, metrics are a compressed representation of the events, and they don't need to be sampled. So again, this is unlike request tracing, which is intended to capture a deep picture of individual requests. Metrics are capturing statistical information more in aggregate, and they're not sampled. So because of the aggregation also, the amount of information they hold is pretty cheap compared to traces and logs, which are very specific to individual events. So let's take a look at some examples of metrics, right? So I think CPU time, everybody knows this. This is like you open the system monitor on your computer and you want to see how busy your CPU is. Another example is memory usage, which could be a couple different things. It could be memory usage of your process, memory usage in the garbage collector, or memory usage even like on your the machine your service is running on. Request latency is a really important one for observability. This is how long my request took. We want to calculate percentiles, and we're interested in more than just the averages here. Another one is the number of active requests. So maybe we already know the request rate, but we want to know how many active requests are there being processed on my service in addition to the rate. So metrics are also usually visualized as time series. I have a graph here which shows that. This is measuring system CPU time as share in each state. So each state is a separate line, which are sometimes called dimensions in metrics terminology. And you can see over time how they interact with each other and how they change. Cool. So what are metrics used for? Very often they're used for alerting. This is like something goes wrong with your application, or you're hitting too many exceptional cases and you want to notify an on-call and make a change. Usually you'll define some sort of alert conditions based on your metrics. These could be like 99th percentile of request latency is exceeding 15 seconds. Another common one would be the error rate is too high. Say 20% of your requests are errors in a 10-minute window. And metrics are also good for observing the performance of your application sort of over time. So how much memory does your application use on average? Or how does the memory change over time? Like, is your memory increasing as the service runs? Is it increasing linearly, which could indicate a memory leak? And again, comparing this with traces and logs, this is telling you about the performance of your system over time, as opposed to just single events in time. Great, so how can we get metrics with OpenTelemetry? There's two main ways. There's manual instrumentation and automatic instrumentation. For manual instrumentation, you'll write code usually with the OpenTelemetry API, which is how OpenTelemetry will generate the metrics. But you can also interoperate with some existing manual metric instrumentation APIs. So for example, the predecessor of OpenTelemetry is OpenCensus. You can use your OpenCensus instrumented code and capture metrics into the OpenTelemetry ecosystem. You could also do the same thing with Micrometer, which is a Java instrumentation API, which we'll see in the demo. So there's also full auto instrumentation, which is the Java auto instrumentation agent is a good example. You don't have to make any code changes to your application. You just run your code with an agent or a wrapper and you get telemetry out. An important note is these are not mutually exclusive. So you can actually use auto instrumentation and slowly add manual instrumentation. You don't have to do one or the other. Great. So yeah, let's see a demo of Java auto instrumentation, and we're going to see how it interoperates with the Micrometer metrics API. The purpose of this demo is I have a Java Spark application like a web service, and I want to show how we can go from having no OpenTelemetry instrumentation and maybe an existing instrumentation from another API to integrating with the OpenTelemetry ecosystem and collecting telemetry, sending it to either Prometheus or wherever we like Google Cloud Monitoring. So let's jump right in. You'll see I have a really simple web app written with Java Spark here. There's two get endpoints, hello and foo. They're both going to take a little bit of time. Hello will take around 50 milliseconds and foo will take around 500 milliseconds. So there's no OpenTelemetry instrumentation here at all. There's no OpenTelemetry imports. The only thing we have here is this micrometer instrumentation. So we have a micrometer timer, which we're using to record the duration that the work is taking for both of hello and foo. So we're expecting hello to take around 50 milliseconds and foo to take around 500 milliseconds. And finally, we have a middleware, which is recording the request count at the end of each request. So this one's going to be tagged with the path and with the HTTP status code. So we should see separate time series for all the endpoints we hit and for any errors that are returned. Cool. So let's start out just by running the application. I've already built it. So you can see I have these jars present. This is the jar for this example that we're going to run. And I have the OTel agent and the GCP extension for the agent that I'm going to use a little bit later on. So first, let's just start the example app. It starts right up. And this is not going to be sending metrics anywhere. We didn't run it or tell it to send anywhere, but the web app should work nonetheless. So I can hit both of those endpoints. Right. So if we look in Grafana, you can see that I don't really have any metrics in here right now. I just have whatever's coming from Prometheus server. So let's go ahead and run with the Java agent now. So the way you do that is you specify the Java agent jar, and it takes a few flags. So we're going to say use the Prometheus exporter, and we're going to turn off the trace exporter for now. And then we'll run our jar, which was the example. So when I start it now, you'll see initially we're getting some new log messages from OpenTelemetry as it starts the agent. And then we see again that message that the application is up and running. So let's go ahead and send some requests again. Cool, seems to be working still. Right, so if we come to the metric browser in Prometheus now, we see a bunch of metrics. We see these HTTP metrics and Java garbage collection metrics, which are coming from OpenTelemetry. But you'll also see the micrometer instrumentation is getting picked up too. We see my request count and we see the work duration, which was the timer that we set up. If we look at the request count total, remember we sent 2 curl requests to the server at foo and hello, and the status looks good. What happens if we send to an endpoint that's not on here? All right, we got a 400. Let's go back to our chart and see what happens. Okay, cool. So you see this blue line showed up with the status code 404. Great. Now I'm going to send some load to the application. I'm going to send a bunch of requests to the hello and foo endpoints. Let's get that started. This is sending 60 concurrent requests to each of them. And we're going to see how the duration looks in a little bit after this runs. Cool. So I have this dashboard that's already set up, and it's showing that work duration metric as a heat map for the 2 endpoints we have, hello and foo. And you can see data starting to come in now that we're running some load. You can see this heat map is showing the number of requests that fall within each bucket, and the color is showing you how many requests there were. So you recall for hello, we said that one's going to take around 50 milliseconds, and that's what you can see here. This bucket from 25 to 50 milliseconds has the highest count, and we have sort of like a distribution around there. And for foo, we said that one would take around 500 milliseconds, and we see that too. The bucket with the most counts is this 500 to 750 milliseconds. Cool. So what happens if we want to send a GCP? So all I have to do is update my invocation of Java here. I specify this Java agent extensions jar, which has the GCP exporters. I specified to use the Cloud Trace exporter for traces and the Cloud Monitoring exporter for metrics. And I've specified a more frequent export interval since this is a push exporter. And let's go ahead and run the jar again. Cool. So it looks like it's up and running. I'm going to send some load to the application. And let's go ahead and wait a little bit and take a look at our metrics and in GCP. So the application has been running for a little while, sending data to GCP. I've gone ahead and opened this in Cloud Monitoring. I selected the work duration metric again, that's coming from Micrometer. I filtered it down just to the hello path, and we're looking at the same heat map that we saw in Prometheus. The median 50th percentile is right around 50 milliseconds. And we're getting traces now as well, which are being shown as exemplars. So you see this one is right under 100 milliseconds duration. And it has the same fields as the metric that we're looking at. Great. So I think what we saw in that demo was how well OpenTelemetry can interoperate with existing metric systems, right? In the example, we started out sending metrics to Prometheus with the auto instrumentation. And we even were able to get our micrometer instrumentation to go there too. So we saw also we can switch the metric backend very easily. The default in OpenTelemetry, at least in the Java agent, is the OpenTelemetry protocol. It also is built with some open source protocols and backend support, like Prometheus, which we saw. When we wanted to send to a specific vendor, like Google Cloud, we had to add an extra jar, but we were able to just add the jar and it plugs right in. And what's cool is you can even send to multiple backends at once. So here's an example that I captured of CPU time in a application. I sent it to both Prometheus and I sent it to Google Cloud Monitoring. And we can see that over time, they're exactly the same graphs. We don't even have to run an agent or copy one data out of the other one. We can just get them both from our application at once. Cool. So that was auto instrumentation, and let's talk about manual instrumentation for a bit. First, when should you manually instrument? In general, you should prefer to use auto instrumentation or instrumentation libraries. Instrumentation libraries are sort of like middlewares to generate metrics that don't require an agent or a startup script. So for example, you could use a Flask middleware or gRPC interceptors. But sometimes those aren't available, right? So maybe you're using a weird framework that not a lot of people use, you're writing your own framework, or even you want to capture specific metrics about your application. In those cases, you're going to want to write your own instrumentation. So these are the components for instrumenting with OpenTelemetry, and they should look very similar to tracing. Again, you start by creating a meter provider. This is sort of the root of your OpenTelemetry SDK. You'll supply a few fields. You need a resource, which identifies where the telemetry is coming from. You need metric readers, which are sort of handles that are completely independent ways to pull data out of the SDK. And exporters will use these metric readers to get the telemetry and send them off. Finally, you can optionally provide views, which are sort of like a customization mechanism. But don't worry, you don't have to actually supply those. OpenTelemetry has really good defaults. So for example, we support a bunch of default histogram buckets. You don't even have to specify any, and they should work pretty well for most use cases. After you've created a meter provider, the next step is to create a meter. Meters are analogous to tracers in the tracing API. They're meant to be namespaces for the metrics that you're creating in this library. The next step is to create instruments. The idea of instruments is to be similar to real life instruments, right? So you could think of like a thermometer. That's something you use to measure temperature. You would use a counter to measure a count, or a histogram to measure values that are changing. So a few fields on instrument, they all have name, unit, and description. The name becomes the metric name that gets sent out to the different backends, and the description and unit get passed on as well. So you can identify, what does this metric mean? And you can identify, oh, is it seconds or milliseconds or nanoseconds? And a lot of visualization tools will know what to do with that. So finally, once you have instruments, it's time to make measurements. A measurement is like a metric event, and all measurements will have value and they'll have attributes. So attributes are like those dimensions. So for example, we showed in CPU time, you could have the different CPU states like user and idle. So note from the tracing section, you also have resource, attributes, and context in metrics as well. And this isn't a coincidence. The idea here is to correlate your telemetry. So the resource is where the data is coming from, and you can match that up with where your traces are coming from. And in measurements, you have attributes and context, which are generally the same thing as they are in tracing. In fact, since the context holds the trace context, that's how exemplars work that we saw in the demo. When we see a context, we can extract the trace context and say this metric is correlated with this trace. Great, so let's look at what that looks like in code. I have some sample code here, which is setting up a SDK to send to Prometheus. So first you'll create the exporter, create the meter provider with the exporter's reader, and you'll pass the resource. You'll also want to set the global meter provider. So generally, you'll only have a single meter provider in most applications. Calling set meter provider just makes it easier for other libraries to access that meter provider. So the next step was to create a meter. You can just call get meter once you've set the global provider, very easy. The name field here, again, is to identify the meter as a namespace for metrics. You could think of most logging APIs, you pass a fully qualified class name to them, so you can identify the log is coming from that file or that class. It's the same idea here. So if you have maybe a metric that's misbehaving, you can just turn it off altogether because you know where it's coming from. Next, you want to create instruments. So in this example, we're going to count the number of orders that a service processes. The instruments are usually also part of initialization, so you'll create this and use it repeatedly. And again, note the description and the unit. These are part of the data model. Cool, so now we're ready to measure, right? So this example is we have a function to batch process orders for a given region. What we're going to do is process the orders and then add the size of the batch to our counter. And we're going to specify the region as an attribute, which makes a separate dimension in our graph. So here's how that looks in Grafana, which I created this with Prometheus exporter and Grafana. Each line is a separate dimension. So green is east, yellow is west. We can see how the two interact and we can see how they change over time. Cool. So there's a few different kinds of instruments in OpenTelemetry. Let's talk about how you choose them. Counter is for monotonic sums. So something like how many errors are there. Updown counter is for non-monotonic sums, which is a little weird. We'll get to that in a bit. And histograms are for distributions of values. For each of those kinds, there's a synchronous and an asynchronous version. So synchronous instruments are for making measurements directly. Like we saw in the previous example, you'll call orders process.add when you process an order. And asynchronous instruments are for observing a value periodically with a callback, right? So in this example, we want to see how long the queue is. Occasionally, we'll just check the length and report that. So let's just look at a few examples and see how we would instrument them, which instrument we'd use. So if I want to count the number of HTTP errors, I would use counter. If I want to measure the request latency, I'd say I want to get more than just the average. I want to see the distribution of values. Yeah, I would want to use a histogram so I can capture the distribution of measurements. This is great because we can calculate percentiles for alerts and we can generate heat maps like we saw in the demo. Okay, here's an interesting one. Say we want to count the current number of active requests. So it's a count, but it can go up and down as we enter and exit the request handlers. I would use an up-down counter for this one. So the nice thing here is all we do is add one and subtract one from our count when we enter and exit the handler. And OpenTelemetry will automatically keep track of these counts for us and add them all up. Okay, I think this is the last example. We want to periodically report the CPU time of the system. So the CPU time is tracked by the OS. We should use an asynchronous counter so we can occasionally scrape or read the CPU time from the OS and report it with a callback. Great. So that was instrumenting with OpenTelemetry, and thank you for your time.